Today, we are digging into a pretty wild idea. What if consciousness isn't just some deep mystery locked inside our brains, but is actually a mathematical result of cooperation? We're going to explore a framework that tries to put numbers to this connection, a formula for how systems, including us, evolve toward higher intelligence. All right, let's just jump right in with a massive question. What if there was one single, universal formula that explains how cooperation works? Not just for people, but for everything.
I mean, think about that. A single mathematical idea that could explain the incredible stability of an ancient rainforest and give us a roadmap for the future of our own minds. It sounds kind of like science fiction, I know, but the math behind it is surprisingly down to earth.
So where does this formula come from? Well, it's at the core of something called the Modified Energetic Lotka-Volterra framework. Let's just call it MELV, it's way easier. And it's all about looking at the world through the lens of how much energy interaction costs.
The whole thing revolves around this one idea called the I factor. And it's actually pretty simple. Just think of it as a score for friction, or the cost of competing. It doesn't matter if it's two animals fighting over food or two companies fighting for market share. A high I factor means you're wasting a ton of energy on conflict. So, here's the magic number you need to remember, 1.0. If that I factor is above 1, competition is pretty much the default strategy. It's just what happens. But if you can push it below 1, you enter what the framework calls the window of opportunity. And this is the zone where suddenly cooperation becomes the smarter, more energy-efficient path forward.
So, the big question is, how do you actually do that? How do you get that friction factor below 1? Well, the framework tells us it really boils down to two main ingredients. Let's break them down. Okay, so to bring that friction down, you've got these two big levers to pull. The first one is phi. That's an internal thing. It's all about how mature or, optimized a system is. And the second is beta. That's external. It's about the environment itself. Is it even set up for cooperation to happen?
Let's zoom in on phi for a second. It's basically a score, right, from 0 to 1, telling you how mature something is. An ancient, stable rainforest that's been perfecting itself for millennia, that's got a phi way, way up there, like a 0.95. But some new invasive species that's just arrived and is causing chaos, its phi is going to be super low, maybe a 0.2. It just hasn't figured things out yet.
And then you've got beta. This is all about the playground, the context. A place like a tropical rainforest is just bursting with opportunities in different niches, so its beta is super high, maybe 0.90. There are tons of ways to get along without fighting. Now, compare that to the Arctic tundra. Resources are scarce, competition is brutal. That is a low beta environment for sure. We're talking maybe a 0.30.
And this is where it gets really interesting. See, it's not just about how mature you are, and it's not just about how nice the environment is. The real magic happens when you multiply them together. That product, phi times beta, gives you a hard number, a real quantitative measure of just how stable and cooperative a system can be.
But wait, there's one more piece to this puzzle. And honestly, for us humans, this is the one that changes the entire game.
This one's called epsilon. And all it really measures is speed. How fast can a system learn to cooperate and push that I factor down? You could call it evolutionary plasticity, but really it's just the learning rate. And man, when you see the numbers, it's just staggering. Look at this. Genetic evolution, the slow, grinding process over eons, it has an epsilon of maybe 1. But human cultural evolution, we're talking an epsilon of 8 to 10. It's like we have an evolutionary turbocharger. We can figure this stuff out in a few decades, not millions of years. And then look at what's coming with human-AI collaboration. The potential learning rate is just off the charts.
Okay, so this is what it's all been leading up to. How do we take this cool mathematical idea and turn it into a practical roadmap for our own minds, for our teams, for our organizations? Let's lay it out.
First up, let's talk about phi in our world. For us, phi is really about cognitive maturity, and a great way to measure that is by looking at the planning horizon. A low phi is a panic response, right? You're only thinking seconds or hours ahead. Normal corporate planning, looking out a few years, maybe a decade, that's a mid-range phi. But a high phi, that's when you get to real conscious systems thinking across generations.
Okay, now for beta. In our world, beta is all about the environment, your company culture, your community. Is it a cutthroat, zero-sum game where everyone's out for themselves? That's a hostile, low-beta environment. Most places are somewhere in the middle. But a high-trust culture where collaboration is the default, where it's actually rewarded, that's a high-beta environment, and it's where cooperation can really thrive.
And this brings up such a critical point. You could be the most brilliant, long-term thinker on the planet, a super high-fi. But if you drop that person into a toxic, low-beta culture, their potential is completely wasted. It's the product of the two. You need both the individual capacity and the supportive environment for real cooperation to take off. So this gives us a surprisingly clear step-by-step roadmap. Step 1, you got to look at the environment first. You have to measure and improve that beta context to even make cooperation possible. Step 2, you work on the inside. You nurture that cognitive maturity, that hi-fi capacity for big-picture thinking. And then, step 3, you hit the accelerator. You use our amazing human epsilon to learn and adapt these cooperative strategies faster than anything else on the planet.
And it all comes together in this one elegant equation. It shows how that friction, that interaction cost I, goes down over time. You start with some initial cost, and then you just subtract the combined power of your learning rate, epsilon, your cognitive maturity, phi, and your environmental support, beta. That's it. That's the engine for driving down conflict and building up cooperation. This is the math of conscious evolution.
So you see, this is way more than just a neat theory to describe how things are. It's actually a toolkit. It's a blueprint we can use for actively designing better, more cooperative, and way more intelligent systems.
All right, so let's just quickly wrap up the big ideas here. First, cooperation isn't just some random hopeful thing. It follows predictable mathematical rules. Second, those rules are built on two universal blocks: maturity, our phi, and compatibility, our beta. Third, we humans have this incredible secret weapon, epsilon, that lets us accelerate cooperation like crazy, which means this whole framework is a practical guide for building better systems. The end goal? To get to a state where the product of our maturity and our environment is so close to one that cooperation becomes the easy, natural default.
And that really leaves us with one last massive thought. If cooperation really does have a formula, a recipe that we can actually follow, then the future isn't something we just have to wait for. It's something we can actively build. So the real question is, what systems are we going to choose to build with it?